This video is to help you revisit the skills from Unit 1, Topic 1, SLT numbers 1 through 5, the inverse relations. Let's take a look at our first example, applying the concept of inverse in given directions in real-life scenario. Suppose you are given the following directions to get to Edwin's house. From home, go north on Route 23 for 5 miles. Turn east or right onto Orchard Street. Then go to the 3rd traffic light and turn north or left onto Avon Drive. And then Edwin's house is the 5th house on the right. If you were to start from Edwin's house, write down the directions to get home. Sometimes it's helpful to sketch the given directions. In this case, let's utilize the given illustration to write the directions to get home. So I'm going to start from Edwin's house and turn south to Avon Drive. So we can say turn south or turn left to Avon Drive. So I'm going to pass 4 houses on the left and arrive at the traffic light at Orchard Street. Then I'm going to turn right onto Orchard Street. So I'm passing 3 traffic lights and then turn left on Route 23. And then I'm going to travel 5 miles to home on the right. Another example showing inverse relation is when we are given a verbal description to write a function and its inverse. Let's take a look at this example. The verbal descriptions are as follows. Starting with the number, subtract 2, take the square root of that quantity, and add 5. In this type of problem, we can utilize the do and undo chart. Starting with the number x, we subtract 2. We take the square root of that quantity and add 5. For the undo side, we take the opposite operation of everything that we've done in the do side. Starting at the bottom, we subtract 5. The inverse of the square root is square. And the inverse of subtract 2 is add 2. Now that we completed the do and undo chart, we are now ready to write the original function and its inverse. Let's write the original function using the verbal description we have on the do side. Let's use f of x as our function notation for the original function. So f of x is equal to, we start with the x, subtract 2, take the square root of that quantity, and then add 5. Notice that my square root symbol stops at -2. The plus 5 is not included in that quantity. Now let's write the inverse using the description we have in the undo side. Let's use f to the -1 of x as our inverse function notation. So similar to how we started on our do side, we begin with our x, subtract 5, square that quantity, and add 2. Another example that we can apply the inverse relations is in word problems. Let's take a look at this example. Maya sells makeup for Unique and she makes a base salary of $1,600 in addition to a bonus of $20 for every sale she makes. Let's write a function that will help Maya determine her monthly paycheck. Remember, in writing function, we will need to know the variables, the independent and dependent variables. In this problem, the independent variable is the number of sales, in which we will use S. The dependent variable is our monthly paycheck, in which we will use P. So writing the function, the monthly paycheck is equal to $20 times the number of sales plus the base salary of $1,600. Now Maya was bragging about how many sales she made but forgot the exact number of sales she made last month. However, she knows she has her last paycheck. Write a function that will help Maya determine the number of sales she made based on her paycheck. In this case, for us to be able to help Maya determine this number of sales, we will need to use our knowledge of inverse relation. Let's write the inverse of the equation that determines her monthly paycheck, which is P is equal to $20 times the number of sales plus 1,600. Now, utilizing our knowledge in writing the do and undo chart, writing out the do side, so we start with the number of sales times 20 and then plus 1,600 to determine her monthly paycheck. Doing the undo side, taking the opposite of plus 1,600 is subtract 1,600. The opposite of times 20 is divided by 20. So writing the inverse function of her monthly paycheck function is going to be S, the number of sales, is equal to the amount of her monthly paycheck minus 1,600 divided by 20. So this equation will determine the number of sales she made based on her paycheck. Another example that we can use the inverse relation is when we are given set of ordered pairs, like so, or sometimes when we are given table of values. The idea of inverse relation is when we switch our x and y. So if we have the first ordered pair -13, 5, its inverse is going to be 5, -13. If we have -9 and -9, so we switch it. Since they're just the same, we can keep it. And then if we have the next ordered pair -5, -2, its inverse is going to be -2, -5, and so on. So we're just switching x and y. Keep in mind, we're not switching the signs. We're only switching the x and the y. not the signs. Another scenario that we can apply the inverse relation is when you are given the graph. Let's graph the inverse of f on the same set of axes. Sometimes it will be helpful if you're gonna identify at least 3 distinct points. In this case, we have positive 1, 4, negative 1, negative 2, negative 7, positive 2. Those are the 3 distinct points that I can label. Now switching your x and y, your set negative 7, 2 becomes 2, negative 7. Your 1, 4 becomes 4, 1. Your negative 1, negative 2 becomes negative 2, negative 1. Plotting those points, the inverse of the original points in the same axes, we will have these 3 distinct points. Now, how will you know that our points are really the inverse of the given original points? You're going to have to make sure that the points is reflected over the y equals x. This is going to be our line of symmetry. So the 1, 4 is reflected over that y equals x. The negative 1, negative 2 is reflected over the y equals x. And the negative 7, positive 2 is reflected over the y equals x. And there you have it. I hope this helps.